Welcome to the upstreamlife.com, a podcast that celebrates transformation in India. I'm your host and founder, Vishal Krishna. You guys know I'm inspired by the power of ideas, and I intend to capture stories of people who believe in change. I fundamentally believe in nation building. Today, I have with me someone who has indeed been on that journey for several decades. In his capacity as a leader in several companies, he has helped change Indian mobility, and he is also setting the context for its future. I have with me Dr. V Sumantran, a technocrat, a author, an engineer, and a polymath. Dr. Sumantran is the founder of Celeris Technologies and is on the board of several organizations. He is also the co-author of Faster, Smarter, Greener, The Future of the Car and Urban Mobility. Sumantran is an alumnus of the Indian Institute of Technology, Madras. He graduated in 1981. He has a master's degree in aerospace engineering from Princeton University, where he graduated in 1983. He went on to receive his PhD in aerospace engineering from Virginia Tech. From there on, he's worked with some marquee names like General Motors, Tata Motors, Ashok Leyland, and many more. He has pioneered the development of frugal innovation. We're going to talk about it in this podcast. He was a part of the Tata Nano project, which was a low-cost car truly built for smart urban commute. Let me paraphrase a quote from his research paper. Urban mobility is transforming to a connected, heterogeneous, intelligent, and personalized architecture. He calls it CHIP. A chip mobility architecture makes room for automakers, technologists, city planners, and entrepreneurs to innovate and proliferate new travel modes and solutions, enhancing variety, options, and utility for users. Doctor, welcome to the Upstream Life. There's so much to chat with you. Thank you. It's an honor for being on this podcast. Thank you so much.
It's a pleasure, Vishal. I've always enjoyed our interactions, and I know of your passion for engineering, nation building. So it's my pleasure to join you here.
I just want to ask you quickly. You had such a wonderful career. How did that love of engineering come to you? I mean, is it because of your parents? I remember many years ago, you were talking about your father having heard stories of M. Visvesvaraya. And that was the conversation that we had, that the man who inspired us all was Mr. Visvesvaraya, Sir MV, as we know him. And did your love for engineering start from those stories?
In a way, yes. I suppose as the third generation engineer in a family, it's kind of in your blood. And I don't suppose there was any point in time where I seriously thought about what my career should be. It was almost a given, a natural. Yes, my grandfather was an engineer. When I think back to the kind of things that generation achieved, a person who really lost his father at a very early age, of his own, coming out of rural Tamil Nadu, coming to Chennai, going to at that time, the engineering college, getting an engineering degree, then somebody, recommending that he goes to the Indian Institute of Science, the Tata Institute at that time, when people like Sir C.V. Raman and Sir Visvesvaraya were all, icons, for him to go there, do a master's, and from there to head off to Germany in 1922. Can you imagine Germany just after the World War, in ruins, but having the aspiration to go to Darmstadt and do a PhD in electrical engineering? In those days, it was just called electromachinery. These were all generating power generation as electricity was just coming in. So yes, there was my father being a very committed engineer, and of course over the careers they all became managers in industry, heads of industry. So there was a lot of, shall I say, subconscious motivation and subconscious mentoring in the family. So to me, it was almost a natural.
Okay.
Were you more of a
builder? Were you more of a builder?
Well, I really, and I will come to this later, but I have kind of defied being pigeonholed through my career. So it was all sorts of experience. And for example, to your point of builder, one of my role models when I was growing up used to be this phenomenal legend in Mercedes-Benz in the pre-war and in fact post-war years as well. Dr. Rudy Uhlenhaut. And it was the aura of the man was he had a PhD, he was a mechanical engineer, he built the masterpieces at Mercedes-Benz, the 300 SL, the 300 SLR. But the story goes that he could get into the race car and lap the Nürburgring within a second of the time that Sterling Moss would do it. So what was he as a builder? What was he as an experiencer of engineering? So these were all major role models. So yeah, I think there is a sense of immersion into a subject, and without any dramatization, to me, it was almost natural. It was just immersion. And it helped that the hobbies were things like autos, flying at a very early age, motorcycles. So I got into this almost in a way like fish takes to water. And it helps if you build your career in something you love doing. So it's been a very joyous ride. Actually.
Did you ever get to meet Rudolf Uhlenhaut?
No, sadly he passed away before I really became old enough. But I did a very audacious move as I was leaving IIT to head to Princeton, never having been outside the country before then. I audaciously wrote to the research departments at Mercedes-Benz, Porsche, MBB, and I said, hey, I'm a student, I'm going to the US, I want to stop in Germany on the way and I want to visit you. And you wouldn't believe, all of them replied positively, and I had a wonderful visit to the Unterturkheim Technical Center of Mercedes and met his successor generations of leaders, and indeed Porsche and MBB and so on. So sometimes, I think it's like the title of the book by Obama, Audacity. But it helps sometimes.
And when you're a young person, you really don't care. You just write to them. And did you write letters? There were no emails then. Absolutely, right?
Typed on a mechanical typewriter and sent as an airmail letter.
Interesting. And I want to get back to that, youth. But for those of you who don't know, Rudolf Uhlenhaut was the technical director of the racing department at Mercedes also. And like Sir said, he's also the one who got the SL out in the very early days, right? The 300 SL, I think, was
absolutely
right. So, how was childhood like in Chennai for you? I mean, the 70s leading up to IIT. Did you choose aeronautical as a space because you liked flying at the time, or was it something that interested you? And back then, for those of you who don't remember it or very young and listening to this podcast, we had very few cars. We had about two, three brands in India, right? And how was that like? Growing up in Chennai, I think that was a big metropolitan city at the time in India. And a lot of people would look to Chennai for the engineering also. What was it like leading up to college and IIT? How did that happen?
Well, even in my high school days, we had a bunch of friends. We were totally crazy about cars and motorcycles. We'd sit at the back benches, keep drawing and doodling cars. We were fortunate in Chennai because it was a bit of a motorsport city. So we had Sholavaram, we had the races every year. And I would, even before I was old enough to drive a car or ride a bike, we'd be tuning motorcycles for racing with a few friends. And they'd go out and race in Sholavaram, which was once a year, which was a big deal in those days. But in fact, when I've met with the UK High Commission, I've also, shared with them the phenomenal connections they had built. We used to have the British Council in India and in Madras in those days. And, this is today in an age of internet and access to information, we seldom appreciate how hungry we were for information. I remember pedaling 10 kilometers to the British Council Library just to see if the latest issue of Autocar or Motorsport was there. And inevitably, the airmail shipment may not have arrived, and you just see the same issue you've seen the last time, and you go away disappointed. But we got to, read all of the classics. I mean, Dennis Jenkinson, people who were, bywords in motorsports journalism or automotive testing and journalism. We got to read them, and we would devour whatever they would write those days. And many, many years later, in fact, when I was launching the Tata Nano the Tata Indica as the city rover in the UK, I got to meet some of these journalists, and some of them were surprised that some obscure 18-year-old was reading what they were writing in those days in a faraway country. But yeah, we had that immersion. But I also, Chennai also had at that time the Madras Flying Club. And there again, I was fortunate to have a grand uncle who was one of the early pioneers in private flying. So with his encouragement, I actually enrolled in the Madras Flying Club. And in those days, you could be given a student pilot license at the age of 17 and a half. So I actually got my student pilot license at the age of 17 and a half.
Why 17? Very, very curious.
I think they figured it would take you at least half a year or more to get ready for a license, by which time you could get your license at 18. So I remember actually having even been stopped by the police on my motorcycle coming back from the flying club, saying, "Are you old enough to have to ride a motorcycle?" And I used to rhetorically ask the question, "If I'm old enough to fly an aircraft, why can't I?" But yes. Well, you got away with some of these things. So flying came also very early, and I literally got my flying license a little over when I was 18. So motorcycles, cars, airplanes. I mean, as they say sometimes, my mother firmly believed that I never finally ever grew up, and I never grew out of my toys. But it's been a fun ride because of that kind of enjoyment and passion.
Joining IIT, was it a rat race in those days, or was it more of a passion? Today you have kids, parents who, I mean, you had such a beautiful childhood, learning about cars, learning about bikes, planes. But today, I mean, and the whole race to IIT today is to have a pedigree behind you, and it's almost as if it's forced down your throat, rather than saying, can it happen naturally? And for you, what kind of a situation was it at the time when you got into IIT Madras?
There was no doubt that we'd grown up. I mean, I was fortunate to go to a good high school, and subsequently, in those days, we had the pre-university program. We went to a good college for the pre-university. I think, and this may be true even today, the population of young people we have in the country, if they get motivated, in some senses, perhaps even intensely competitive, you literally get sucked into this race for competitiveness. And when all your peers around you are similarly motivated and competitive, it kind of drives the whole population to something else. I don't doubt that it is any different today. If you go to the cohorts at, say, an MIT or a Stanford, I think just putting your son or daughter there immerses them in a pool where everybody is motivated and committed and competitive, and it drives a greater sense of effort and a greater sense of expectations, I suppose. So for us, it was competitive, but again, you moved from high school to pre-university to IIT with a number of cohorts. So you never ever had the feeling that you were doing something special. There were lots of people around me who were smarter than I was, who were more accomplished than I was. So there was never any great sense of accomplishment, but it was definitely motivated by a sense of this was expected of you, and you literally moved with your cohorts through the stages. So I suppose we never, of course it was competitive, but I can't feel negative about the so-called high pressure.
Absolutely.
Situation.
I'm glad you could add perspective to that. 2 years there, and you quickly fast-tracked yourself to Princeton, right? And from there, Virginia Tech. That was quite an accomplishment. I mean, the PhD was done by 1985. You were done with the PhD, I believe, right?
Yeah.
I mean, was it?
I was in a bit of a hurry.
Why was that? I really want to know.
Well, again, sometimes serendipity is important. I had gone to Princeton, and I had always been fascinated by low-speed aerodynamics. Again, to the disappointment of my mother, I think she might have wanted me to, when she heard about aerospace, she said, good, you're going to do something really fun, exciting. Maybe you'll work for NASA, maybe ISRO, you'll work on space. And here I was steadfast in my interest in low-speed aerodynamics, which she was a lovely person, but she'd always say, why low speed? But for me, it was all this experience. You experience what you can at low speed. Nevertheless, so I went on to do my master's at Princeton, where I had a lovely bunch of friends, one of whom was lots of car guys. You kind of gravitate to this company. And he actually went off to work with General Motors at their research center, GM Research Labs. And he was a couple of years older than I was. And so very soon after he got there, he said, hey, you know what? We're looking for an aerodynamicist. You're an aerodynamicist. Why don't you come and apply for a work to join a job at GM Research? And I said, listen, I'm just into my first year at PhD. And so he said, nevertheless, what you do is come over, have an interview. So I flew to Detroit. GM invited me. I had an interview, and lo and behold, they said, yeah, we want you here. And I told them, listen, I'm 1 year into my PhD program, and I'm not going to quit now because I don't believe in leaving and trying to finish my PhD late. I don't know if I'll ever finish it. But this was, there was a lot of things in the US and in large corporates in the US in the 70s and 80s. That was all about, the big picture, big vision. And there was a certain generosity about what they wanted to do. So GM basically said, never mind, go finish your PhD. When you finish, we'll be here. So I went back and I told my advisor, hey, I got a job already. How long will you take to let me go? Let me finish the PhD. And he said, well, it's your job. It's all up to you. So I worked like hell because I was eager to get going. And so in a way, I really never even applied for a job with my PhD. I was more in a hurry to finish the PhD because the job was waiting. And that was, in a sense, the motivation to get done with the job, with studies and get on to a job.
All of 26, I think, right? When you finished this PhD, just 26?
Yes.
And was that a 15-year stint with the GM after that, or was that the period time?
Yes, I think I stayed with GM till 2001 when I came back to India. So it was about 16 years. And honestly, even today, the former CEO and chairman of GM, Rick Wagner, is a close friend. While GM's gone through ups and downs, many of us who had been in GM at that time only have wonderful memories of the place. It was a wonderful company. The GM Research Labs were akin to the Bell Labs in communication space. So we were really working on problems that were way out. I mean, we talked today about virtual reality with haptic feedback, and we were playing with that in 1989. We had virtual reality immersive caves, and we were working
what they call Web3 and what they call metaverse now.
Yeah. I mean, this whole business of immersive reality with haptic feedback, and you touch knobs and you turn knobs and you feel the resistance. I mean, these were tools we were playing with in 1989, 1990. And it was a measure of the kind of work that the GM Research Lab were doing in those days. So it was a wonderful experience. And the other nice thing about the corporate cultures those days was they had the confidence that they would tell their employees, do what you want and work to your potential. At GM Research, we had a wonderful vice president who was a former administrator at NASA and a member of President Carter's Council of Scientific Advisors, and Robert Frosch, remarkable man. And he used to say, our job should be to hire bright people, and in his words, let them swim in a sea of ideas. And so we were working with a whole bunch of, we were developing the first fully arbitrary geometry, finite volume, computational fluid dynamics codes before any of those codes existed. In fact, something we did in collaboration with the Imperial College in London later became the most widely used commercial CFD code. And all of this 20 years later, we were working with this 20 years before it was even a commercial product.
Wow.
So it was a lovely experience to be at a place like that during the early years of working.
I want to quickly talk about changing mobility, or then bring in your time with the Tatas, of course, in between. I'll bring it in. Uh, we had clunky cars in the 60s, 50s, 60s, 70s, huge, nicely designed, but very big. Obviously, gasoline. You've seen I mean, the world had I think, a banking crisis around 87, 89. And then I think we had the Asian crisis in about 96, 97. And 2001 happened. I mean, the software bust as well as the 9/11 attacks. And then we had 2008 that happened, and now the corona that's happened, right? You've seen all this, and mobility, how has it changed? Because one of the primary questions that I think you're passionate about is the way cities are becoming larger. I live in Bangalore, and I would have never thought Bangalore would be a 10 million plus city in 15, 16 years. It was Bangalore back days was just a retirement kind of a place. It is, in one hand, a good thing because you get a lot of talent flowing into each city, but it's also a nightmare because of the mobility situation. For you today, mobility is not just about cars, it's a whole encompassing thing. I want you to talk about why do you make these notes about the chip architecture that you talk about, and that we need to implement these strategies by 2050. Otherwise, we are going to live in a highly damaged society, right? There was this research by an economist who said if we can get to the metro in less than 10 minutes on the pavement or a footpath, it adds X number of points to the GDP because people get to work on time. So on that context, right, it's a question based on your experience in the current state of affairs. How is mobility changing?
So if you take that period between, say, the 70s and then, do a fast forward to that, what we saw in the 70s through the entire auto industry globally was a huge emphasis on environment because we had the oil crisis, we had fuel efficiency, fuel economy improvements. For the first time, people were talking about CO2 emissions. And very close in tandem to that, we found emphasis on safety, automotive accidents, human fatalities, and so on. So there was a lot of work focused on these areas in the 70s and 80s. A lot of them actually motivated by regulation. In fact, sometimes people ask the question, do regulations have a role to play in innovation? And absolutely, yes, they do. A lot of the innovation in the auto industry wouldn't have happened without the regulations demanding fuel efficiency or, for that matter, safety. Then we began to see the advent of computers and the power of computers, and therefore we began to see this in the automobiles, in the tools that we're using for the automobiles, and so on. So to come back to the last section where you want to fast forward to the transformation, the book that we talked about, Faster, Smarter, Cleaner, I decided in the early 2013-14 to take a sabbatical because we'd already seen what we were doing in our companies. GM had acquired EDS, they'd acquired financial services companies. The whole approach was, how do we wrap a consumer around services? Subsequently, in India, and for that matter, even in Ashok Leyland, we were looking at fleet services, telematics, all of this, saying, how do you look at the orchestration of mobility? So we were dealing with a number of key issues. How do you wrap services around a consumer, and how do you address the architecture of fleet transportation mobility? So the hope at that time was I wanted to personally take a sabbatical, go off and write a book. And I want to write a book on what's the architecture of the auto industry for the future. I didn't want to do it on my own. I wanted some academic rigor and, shall I say, validation of what we were going to say. So I wrote to two colleague professors from MIT, Charlie Fine and David Gonzalez, both professors at MIT. And we decided to do this book. And when we were setting out to do it, we quickly realized that when we're trying to answer the question, what should the future of the auto industry be? We found a very surprising response from many societies and populations. And the reaction was, who cares? Who cares about the auto industry? Now, this is should be linked to the culture where big corporations went from being highly admired entities to people distrusting big corporations. This is one aspect of it. But the other aspect is people in large cities, whether it's Tokyo or Singapore or Hong Kong or London or Paris, really have come to have a different experience of mobility. So we really said the question we should be asking is not what is going to happen to the auto industry of the future, but what's going to happen to mobility in the future. So that itself was a pivot. The moment you say, I want to address the question, what should mobility in the future be? You realize that you cannot answer the question without addressing the context of mobility. And the context of mobility is the kind of cities you have. Obviously, a city like spread out city like Shanghai is very different from a very compact, high density city like Hong Kong. In fact, the first chapter in the book that we have is a chapter called A Tale of Two Cities, where we contrast London with a population of about 10 million people and Los Angeles, another city with a population of about 10 million people, except Los Angeles occupies 8 times the landmass of London to house the same 10 million population. So you cannot address mobility without addressing the architecture. So immediately you have to get into urban planning, land use, and so on. Now, this time we came to a very interesting point, which even in the COVID era is becoming extremely relevant. There's a lovely thesis in a book by Richard Florida, The Rise of the Creative Class, where he talks about the motivations for people agglomerating to cities. So when we talk about cities, I mean, you mentioned Bangalore being 10 million. Yeah, why do people find Bangalore to be a magnet? And the answer is there are huge economic and social advantages, both for the individual and for the city, society, corporates, and so on. For people, individuals, there are better opportunities for jobs, better social interaction opportunities, and so on. And likewise, for employers, there is a larger labor pool, a better concentration of workforce. I mean, why do financial experts all converge on, New York or London or Singapore or Hong Kong? Because of this magnet of opportunity. So there is, that's why around the world, we've seen this urbanization trend. And, we've gone from 1 in 6 being urban in 1900 to by the time we're in 2050, 4 out of 6 inhabitants of the world will be urban. So this is this magnet that is drawing people together. But then you have to address the question of how do you serve the mobility of this population? And this then becomes a very interesting, and I think to me, there are 2 underlying foundational principles that may lead us to whatever the solution is, and it will lead to the chip architecture. The first is, we always talk about sustainability emerging from reduce and reuse. But actually, there is an R before that. And the first R should be refuse. Refuse anything else. If you have a solution, use it. Don't buy a new solution. Refuse, reduce, and reuse. If you follow this hierarchy, you are likely to be naturally more sustainable. I'm sharing an asset that is therefore leveraged amongst a larger user base. If I'm talking about in a city sharing space, the average 10 to 12 square meters of space that a car occupies is already worth about $500,000 in New York City and probably close to that in Mumbai. So you're occupying that space. So if I can share that space, again, I'm on a metro, I'm riding a taxi because that taxi goes off and serves somebody else later in the day. Sharing space and sharing the asset becomes important elements. And finally, sharing the energy. I mean, when Uber went from Uber to Uber Pool, you basically said for almost the same amount of energy, instead of transporting 1 person, I'm transporting 3 people. And then you extend it to a van pool, and then you extend it to a bus, and then you extend it to a metro. So the intersecting elements have to be, how do you share the asset, the economic asset, how do you share the space, and how do you share the energy? So if you take these two concepts of refuse, reduce, reuse, and sharing, you then put them in various combinations, and that's what you get to create what should be a proper mobility architecture for any city. And I will agree that no two different cities have the same requirements. So therefore, you have to vary the parameters to suit the mobility model, say, for a London versus a Los Angeles.
No, that's very deep. I like what you've written in the research. Again, quoting from the research paper itself, you quote a former mayor of Bogota, Colombia. He said, urban mobility, he says, is a peculiar and is very different from other urban challenges like education and housing. It tends to get worse as societies become richer. It's a very interesting analogy for me, simply because of two things. Uh, we live in a world that says you have to aspire to own a house, a car, and everything else that moves on thereon. Now they're saying, you don't have to own anything, you can share everything. But again, I believe that either one is driven by the valuation game. You know what I'm saying? It is not thought through. So what would be your suggestion to a lot of people or leaders listening into this, right? I want you to talk about what does it mean to think through these things. It's not as if we go from one to another and then create problems in this one and then think of another. We can't live that way, right? So your thoughts on this, please.
Well, one of the quotes in the book is attributed to George Bernard Shaw, which he says, science has never solved a problem for society without creating 10 new ones. So, yeah. So, yes. But, at the end of the day, this is a call, therefore, for two or three things. One is any architecture has to be flexible. It has to be adaptable. And of course, I hate to use the word because it's such a cliche, but it's got to be agile. So we don't want to think of a rigid architecture for any city because it's not going to be. Human tastes, human aspirations are different. Let's face it now. Between pre-COVID and post-COVID, pre-COVID, it was nice to preach to people, get in a crowded subway because, hell, you are saving space, you're saving, sharing the asset, and you're sharing the CO2. So lovely, get into a crowded train and you'll be very good. Today, all of a sudden, overnight, the priorities changed. I need my personal space, I need safety, So when human proximity and contact have created other issues, then your mobility architecture has to immediately account for this shift. And therefore, flexibility, adaptability are very important. This is exactly why when we wrote the book, we didn't want to come up with prescriptive solutions of what a city should have. We rather put together this framework and say, let's say what we mean by heterogeneity. And the chip architecture, as you correctly pointed out, is connectivity, heterogeneity, intelligent configurations, and personalization. Heterogeneity means today I can serve mobility with any one of an even wider variety of choices. Whoever thought that a banker would be comfortable going to work on a push scooter? But today you find in London, guys in expensive Armani suits with a backpack and on a push scooter going off to work. So we have had explosions in potential mobility modes, whether it is micro mobility modes, pod cars. We're seeing small micro cars that have come from Renault and Toyota and so on. We shrink the format of mobility and find some ways to address this. In other solutions, we find sharing of mobility is enabled by things like ride sharing, car sharing, and asset sharing, and so on. So we have to bring to bear all of this heterogeneity and figure out how do we connect them most effectively. You asked earlier about this whole business of what was, have I experienced chip? Well, it so happened when I was writing the book, I spent a day in Washington, D.C., where I had three appointments. I had a breakfast meeting, finishing a board meeting in Bethesda, Maryland, at the northern end of the Washington, D.C. area. I finished the board meeting and I drove in my rental car to a friend at McLean, Virginia, the west side of the city, for a lunch meeting. I was running late from the lunch meeting, and my next meeting was at the Library of Congress. I was meeting an author. So my friend told me, hey, this is crazy. If you drive down, you'll never get there in time. Drop your car at the park and ride and take the metro. So sure enough, I parked the car, jumped on a metro, went downtown, got to the Library of Congress, finished that meeting, and then I had a dinner meeting at an eatery on the west side of town. And the best way was to take an Uber to go over there. And after dinner, the guest I was having dinner with was a former director of EPA in the US. And she said, hey, I've got an electric vehicle. I'll drive you back to your park and ride. You take your car. So in one day, completely unplanned, I was mixing my personal car, a taxi ride, an Uber ride, a metro ride, very flexibly. And this basically says, yes. And it was, of course, enabled by the kind of tools you have for connectivity, the ability to have e-wallets and pay your journey and so on. So, in one day, as a foreigner in a different city, I still found the ability to concatenate, to orchestrate a full day's journey, making sure that each journey segment was optimized. I took the train from McLean to the Library of Congress because that was the quickest and fastest way to do it. So this is really what the chip architecture is all about. And then when you scale it up, you're going to have, solutions suitable for college students, solutions suitable for retirees, solutions suitable for office-going employees. So each will be configured and chosen separately, which, by the way, is the personalization element. How I want to go out with my wife for dinner on a Sunday evening may be different from the way I want to travel to work on a Monday morning. So you allow for that personalization with all of this. So it was a personal, unplanned experience of the whole chip architecture. And it was all in one day in Washington, D.C.
Dr. Sumantran, I mean, did a lot of your friends in the automobile world hate you for this research? Because, in the research that you put out there with the data is everything, right? That the average person who owns a car uses it only 4% of the time. It's a very interesting data point, right? And yet it becomes a substantial part of your household income that you pay in terms of a loan for the car, right? In this context, did the automobile company say, what are you talking about? We are yet to build aspiration. Auto companies think that way, right? It's scale. And what about India in this context that you put in? What do people tell you in India when you put out this research?
Well, so the first 10 come to India. The auto industry CEOs, well, they're all bright people and they know what's going on. When I was in Germany with the book, one of the people who helped launch the book with a panel discussion was Klaus Entenmann, who is the chairman of Daimler Mobility Services. So if you look at Daimler, they have a very prominent division called Daimler Mobility Services that owns Flixbus, it owns MyTaxi, it owns parking stations, it owns e-bikes, all sorts of things. You listen to Toyota today, and Akio Toyota says we are a mobility company, we're not a car company. Hyundai is out there talking about the fact that they want to be a mobility company and not an auto company. So I think the auto industry is making that change. So that's I don't get too much grief from them. I think they accept that they've seen the writing on the wall. On the other side, in India, in some ways, we have both an advantage and a major challenge in India. The advantage is that as in many axes, when you look at lots of data and you look at various countries, too often India is close to the start of the x-axis and the y-axis. You measure GDP, you measure per capita vehicle ownership, you measure kilometers of roads that we have per square kilometer of land area. All these measures, India comes close to the x-axis and y-axis. Now that tells us something. A, we have just started this journey to motorization. All those roads are already there. You can't do anything. We are going to build our architecture, our infrastructure over the next 20, 30 years Our vehicle penetration is very low. Our per capita CO2 emissions is very low. So we are early in the trajectory of what we want to do. So that's the opportunity. The challenge is that the kind of solutions we need require a tremendous amount of planning, coordination, and execution. Let's start with urban planning. If you can think of a city having two possible trajectories, I can either become like a Hong Kong or I can become like a Los Angeles. You become like a Los Angeles if regulations and infrastructure lag population demand and population expectation. This is what's happening to a lot of Indian cities right now. There is a sufficiently affordable population that says, never mind, I'll go 10 kilometers outside the city and buy a plot of land and buy an affordable flat. I will commute to work from there, and the metros are not yet there, and the public transit system is not yet very sophisticated. So I just move out there. So we're seeing urban sprawl. And we can't contain urban sprawl unless it's by design and by regulations and policy. The city of London actually took a very enlightened policy in the post-war years. They had a green belt around London, and they literally constrained expansion of the city. They limited sprawl. Now, some people can legitimately argue and say, wait a minute, in the process, it made London an expensive city to live in. Yes, it did. But there's no choice if you want to have a city of 10 million people or 8 million people, and you don't want it to become another Los Angeles or another Houston. Every large city in, in Asia or in Europe, other than what's in China, I won't get to China because I think in many ways they're following the US model, which I don't think is a sustainable model. But if you look at Hong Kong, if you look at Tokyo, if you look at Singapore, if you look at Paris, if you look at London, these are all cities that have started to come together and densify the city. 33% of the French GDP is from France and from Paris. So I think unless we take a conscious effort across so many of our cities, now this is, of course, an element of Indian policy that is split between what the center can do and what states can do. So we have to have better coordination. We have to have better ability to plan how our urban environment grows so that we can implement the right kind of architecture. If you reach a level of sprawl, Indonesia has also seen this. Jakarta is a mess. So if we reach a level of sprawl, then it will be too expensive to remedy it, and you will almost hardwire a certain level of CO2 emissions for any level of activity that you want.
And destruction of nature as well. The sprawl keeps moving, right? It's not going to.
Absolutely.
It's not going to be sustainable. No, it's very thoughtful. My next question was to ask you about India's tryst with mobility in terms of what we got right. In fact, from your answer, it's like we've just started, and we have to react soon to fix this. And the word sprawl is such an important point that you make. And what we need to get right is India has various elements. Like there are advantages. There are startups. There is industry that wants to change. There is also the state and central government kind of separation. Obviously, we have the advantages of a functioning democracy. But what do we need to get right in the next 10 years? I also want you to talk about the role of academia to foster entrepreneurship and mobility. I want you to bring in role of engineering beyond just software, because we seem to be losing out and saying the whole world looks at India for software. And if there is a sprawl, even the talent will become expensive. I think that, right? So, and then we lose our creative genius or whatever for the world in terms of software. So there's so many problems that I'm bringing in here. How do you want to address this?
So one is the degree of planning, the degree of anticipating where the country is going, where cities are going, and therefore being ready with it. Shall I say, it's almost like saying smart allocation of infrastructure. I don't want to use the much abused word smart in the sense of digital and electronic. It is intelligent, sensible allocation of capital investments to infrastructure. You're right, lots of things are being planned. I mean, the number of metro programs in the city itself across the country, I think if I remember right, we've got about 23 different cities with major metro projects underway. The urban green mobility, the push towards bringing electric buses to our cities is something that is very much some of the right things to do. Without the urban planning, a lot of this would still be wasted. So we have to accelerate how we get into that urban planning mode. We seem to be more focused on the so-called, smart city definition, the smart city vocabulary, because it's easy to throw money at electronics and sensors and data. The harder thing to do is to work against the political motivations and the political resistance to land reform, land use reform, land use planning, and therefore curtailment of sprawl. This is something that we have to do. There's a lot of stuff that we can also mold with policy. I think when Japan, in its post-war years, talked about the so-called Kaiji Dosha class of cars. I mean, the Maruti Alto and the Maruti Wagon-R conform to this business of a Kaiji Dosha class, which means the so-called K class of cars. Very compact, very small in space, because Japan had a constraint on real estate. And they said, if you have small cars, we will give you better tax rebates or exemptions, whereas we will penalize ownership of large cars. In India, we've tried to do it in some ways with the sub-4 meter class of vehicles, but predominantly with a high cost of fuel, which is both intrinsic and partly taxed, and the regulations that promote using smaller, more compact solutions are, I think, going in the right direction. I mean, the large number of two-wheelers used in India itself is a great advantage in some ways. While it may not be as advantageous as getting those people on an electric bus or a metro, it still means that each person has a much smaller footprint, a smaller mass footprint of how they commute. And as these get electrified, I think we will begin to see huge advantages in the mobility architecture. I think in terms of the private sector, there is a lot more hope today because we have learned to be a lot more reactive to what the market needs. There is, for I think the first time in many, many decades, not so much worry about can I assemble capital. Capital access seems to be not so difficult. I think there is easier access to capital to fund these kinds of projects. And of course, the entire startup infrastructure ecosystem in India is extremely healthy. You're plugged in very tightly to that aspect of the Indian economy. So that also gives us a lot of room to, or sort of reason to be very optimistic about what can happen.
Okay. I like the fact that you said that we need to have the ability to question the political outfit on reform and change, and that is very important. On a scale of accountability and transparency and rule of law, have you seen a sea change in India from your childhood or in your teen years to now? I've definitely seen economic growth. I've seen Bangalore being lifted out of. There were a lot of poor people in Bangalore, but I don't see poor. I see poor people in San Francisco. I don't see that in Bangalore, partly because of the startup economy here too, right? Do you see that happening? Do you see transparency, rule of law, and accountability as a key factor in all the changes that you spoke about? Is that going to be very important? Is it very important for entrepreneurs to ask for that? Do we do that as individual entrepreneurs, which is dangerous because then it's going to be about individuals getting what they want? How do we do it as, like you said, we need to be a people of nation builders and not traders? How do we do that?
How have I seen the difference in the last 50 years of at least being aware of what's going on. I have a lecture where there's a picture of Mount Road in Chennai,
Yes.
the main artery from 1964 or 65. And what strikes you is for the level of traffic density, it was a relatively wide artery. But more importantly, there were broad, well-paved footpaths. There was a cycle lane. There was a good pedestrian crosswalk or a pedestrian crossing. All of this was part of the architecture. We seem to have, in the rush to grow and in the pell-mell of expansion, we seem to have kind of dropped all this. Chennai talks about inadequate stormwater drains. The same Peñalosa, Enrique Peñalosa, the mayor of Bogota, used to say, the measure of how advanced or how prosperous a city is not measured by the number of flyovers you have, but rather measured by the quality of your sidewalks and your pedestrian walks. So look at where we've come. Many places we put up a metro, but we don't allow people to even walk to the metro because there is not adequate, safe access to the metro because the neighboring side streets don't offer any kind of pedestrian walkway. So there is a lot of this to be done now. Politically, in my years, I have worked with both administrations, and I see motivation from across the spectrum of wanting to get there. But there is still this whole business of, at the urban levels, a huge challenge that we face in coming up with how we plan and grow our cities. And I think this is a matter that is of very high importance for both the central government and the state governments to work together.
We have to bring in role of academia in this. Should our academic institutions focus more on their PhD programs in mobility to become commercial? They need to be funded. Of course, you're one of few people who support such ideas. What is the role of academia according to you? Is it saying that I'm great at research? In India, they say that you should never commercialize research. Whereas if you go to the US, the best billion-dollar companies come from college projects, right? Your thoughts on this difference of, we ultimately want to talk about nation building. So the difference in these two cultures, right, is something that I want you to bring in. And the other thing that also frightens me is we also somehow suddenly want to ape the West in many ways. That's been a cliched term for a while now. And in fact, if you look at the startup ecosystem, it has the San Francisco model in India. It's not built to last kind of a model or built to create institutions. When you talk about Tata's or Leyland, people that, or even General Motors, they're institutions. They created cities, right? Where should we begin? Academia, this role of private academia partnership, is that going to change at all for us?
Very interesting. I think you have two kinds of models around the world, and I'm deliberately exaggerating them so we highlight the bookends. France has a very interesting population of highly accomplished academics. Lots of ivory tower institutions that churn out some really brilliant. In fact, across the world, in my literally 35 years of being in industry, some of the brightest CEOs I've seen around the world have been French CEOs. Extremely bright, extremely talented. And they all come from the École Polytechniques, the equivalent of the IITs of France and so on. But France suffers this big disadvantage between what is theoretical knowledge and what is applied in the economy and therefore builds the industry. The other opposite end of the bookmark is Germany, where I also spend a significant amount of my time. And there is a lovely staircase of the pipeline that flows from the pure science all the way to serving economy, serving society. So, for example, in Germany, you have the Max Planck Institutes for basic sciences, then you have the Fraunhofer Institutes for applied sciences, and then you have the Technische Hochschules, the universities, and then you finally find industry. And if you look, I mean, how many of the German CEOs, a lot of the German CEOs I know are Professor Dr. So-and-so, Professor Dr. Weideke, Professor Dr. Bernard. I mean, these guys move back and forth between academia and industry so effortlessly that it promotes this flow of ideas, requirements, needs, and possibilities between the two worlds. So I've deliberately painted two opposite ends. Now the question is for us in India to examine where are we in. Now we have traditionally started with a model that was closer to the French model.
Yes.
A lot of former IIT senior administrators have all taken pride in the fact that, we don't want to get our hands dirty with industry. We just turn out bright students and they go out and do something. But we've seen that change over the period of time. In fact, it's a very interesting personal anecdote. When we were in the final year of our BTech program at IIT, obviously we all had to do an aircraft design project in the final year. So we, in teams of 4 or 5, we developed each of us, each team, a different aircraft we had to design. But believe it or not, when we finished the whole project, we just finished the whole design of an aircraft, structure, aerodynamics, power plants, control logic, all of that. We found that 70% of the population of the teams had never been inside an aircraft in their real lives.
That was the early India.
Yeah, and you can't blame them. What can you do? That was what was affordable. That was what you could touch. Now, contrast that with today, our students, boys and girls, have a lot more opportunity to get involved with industry. They have a better understanding of what's going on. Many of the startups have really reached out. I mean, I remember Aether, when they were still a college team. I remember, in fact, we at Ashok Leyland were fortunate to have funded the college student project for the core team at Aether before they came out of IIT Madras. So I think there is better opportunities to connect between industry and the possibilities of linking to students and the projects from students.
I think professors doing PhDs in India also should make note. They should take it commercial if they can. Right?
It is an important topic. I mean, I served on the Prime Minister's Science Advisory Council. I was recently on this CSIR committee to look at the transformation of CSIR. And all of these occasions, this topic comes up square and center. How do we increase the mobility for professionals into academia and academics into industry?
No, that's great. I'm coming to the end of the show. And, I know you're a man who's going to be remembered for 2-3 things, which is frugal engineering, mostly. For the Tata Nano and the Renault Kwid, of course, and subsequent I think the Ashok Leyland Dost was also your project at the time, and a successful project, as all 3 had different degrees of success. But frugal engineering is a it's a word used globally. So do you think Indian engineers coined that phrase? I remember Carlos Ghosn saying that it was in India that he found frugal engineering. In 2010, he took it to town to the press, right? When Renault Nissan was launching Noragadam, I think, at that point of time. Your thoughts on being part of that lovely world and that lovely phrase or word to call it frugal engineering must be heartening for people to recognize you on that.
Well, first of all, it's heartening. I think it's also important in a world that is looking at more sustainability. There's this famous poem by Oliver Goldsmith, The Deserted Village, where he talks about at that time the transformation of rural England, because England was going through the Industrial Revolution, and the transformation where he says, in the old days, the land gave you what you needed and no more. This whole idea of frugality, you take what you need but no more. So that is going to be an important foundational principle in any journey that is going to be sustainable. So yes, it was phenomenal that Indian engineering is recognized for being frugal. But I also say that in India, we need to institutionalize that in a different way. And I think you'll understand this when I say this differently. Today, the world of manufacturing beats a path to Japan when we want to learn about lean manufacturing, Toyota production system, just in time, lean inventory, Kanban, Gemba. But just imagine what all these words mean. Japan had real estate constraints. They were a very tiny nation and they couldn't allocate space. So if I'm not going to allocate space, I don't want line side inventory. I don't want finished goods inventory. But that means I have to have flexible production systems. That means I must do a die change in 7 minutes, not 47 minutes. And all this is what led Japan to say, I need just in time, I need Kanban, I need lean operations. Just look at how Japan has turned this disadvantage of land, the cost of land, into a huge advantage in production. Now, if India were to say, for us, material, assets, capital are scarce. So I'm going to come up with ways to do enterprise in the face of these constraints. It's a huge advantage for us across the globe. Not just, we should be in a position, we should earn the right first to teach the world about frugal engineering and frugal enterprise. And I hope we're able to, get that. It's a very profound platform if we can really shape ourselves to take advantage of it.
Now, that's a lovely thought. And I can't leave you without asking these two important questions from my podcast. What's your 30-second guide to happiness? And the second one is books and inspirations.
Well, the guide to happiness comes from a very unlikely source. The Rolling Stones talked about you can't always get what you want, but if you try sometimes, you just might find you get what you need. If you go down the path of more wants, more wishes, more expectations, more assets, I think it's a self-defeating goal. It's a self-defeating path. You will never get there. And so much of our culture, so much of our philosophy teaches us that you have to look inwards. You look for satisfaction inwards. You try to walk away from an excessive focus on materialism. And maybe, as I've grown through the 50s and 60s, I think I've found more logical reason to get this. Maybe it's a school of hard knocks. You go after so many things and you really get frustrated and you say, listen, do I really want that? And then you realize that there is an alternative path to happiness. And potentially that alternate path is also a sustainable path because it immediately decouples you from this rat race of more acquisitions and more assets and more consumption.
Did that change over a period of your 50-year career? I mean, as from a teenager, I mean, happiness changes. And summing up, I didn't know you liked the Rolling Stones. That's fantastic. So you're a great blend of India and the world. I mean that's you're a global citizen, and I think the world needs more of that. It's interesting, right? And I'm glad you said that you can't chase acquisitions and set false expectations. Much needed. And I'm glad you said that this country has that philosophy already. Look inward. That's brilliant, sir. And books and inspirations. It can be people art, and it can also be authors that you like.
The COVID period, now it's almost 2 years now, has forced us all to stay home. And frankly, for me, somehow it turned on I've always liked reading, I've always liked books. And it was a period where I've really consumed a huge number of books over the last 2 years. And there has been a convergence. I mean, I recently went through a couple of years ago, rereading Isaac Asimov's, the Encyclopedia of Science. And you look at, even the Andromeda galaxy has got 1 trillion stars. Now, what the hell are we? What is human ego in the context of in a world where even one galaxy the Andromeda galaxy is so large. And by the way, it's working its way towards the Milky Way, and someday it's going to intersect with the Milky Way, and who knows what will happen. And then you look at the universe, and so science leads you to take a look at, what is life, and oddly juxtaposed to that, very soon after that, I went to reread Adi Shankara's biography by Pawan Verma, and this whole concept of Advaita, non-duality. There is a very important confluence of whatever we know of science and whatever we've learned of our own culture and our own heritage. And both of them ultimately lead to the fact that, in this world of, matter, energy, what is ego and what is the non-I? You can't define a non-I. In other words, Advaita almost seems like an inevitable conclusion when you position yourself in this universe. So it's been a very profound learning. Maybe it has been easier as I've crossed 60 and you become older and you say, okay, what is life all about?
That's a brilliant way to end this podcast. Thank you, Doctor, for being on the show. Thank you so much. For those of you who want to know more about his thoughts, read the book. He's a co-author of the book, Faster, Smarter, Greener, The Future of the Car and Urban Mobility. I enjoyed this. I am going to go take it to many more friends and tell more stories about Dr. Sumantran and what I learned from him today. Enjoy the podcast, ladies and gentlemen. Write to us at theupstreamlife@gmail.com for more. And that's a take, Doctor. Thank you so much.
Thank you.